Okay, we are back. This is Techmath2. We're looking at chapter 12, and we're doing 12.6. So, we're in the red book, and let's take a look at a couple of problems. We're dealing with logarithms again, okay? So, if you take a look at number 58 on page 536. We have S is equal to T minus K log M. And let's see, they said find K just solve for K. Just solve for K. So they didn't give us any variables. So what we want to do is isolate this. So we subtract T from both sides. You have S minus T is equal to negative K log M. And then we're going to divide by negative 1 log M. Divide by negative 1 log M. And now what we are going to do is we'll divide the negative into both of those. So it'll be negative S plus T over the log of M is equal to K. And that should do it. They of course switch the T and the S around. So if you look in the book, it's T minus S over log of M equals K. So a very abstract problem where we had to solve for the variable given. All right, let's do another one of those, solve for D. It's almost the same thing. So from this formula, so we're looking at 59. Let's look at 59. So 59, we have solve for D when F is equal to D plus K log B. So it's the same dog, different fleas. We subtract D from both sides. That isolates. Oh wait, no, don't subtract D. We're trying to solve for D, right? Oops, solve for D. I should have written that down. Well, let's scrap what I started to do. I was going for K again. Much easier. This one's super easy. One step and done. Minus K log B minus K log B. And we're done. So F minus K log B is equal to D. And done. So one step and done. All right. Okay, let's take a look at 12.7. All right, so we're going to go into the rules of logarithms for 12.7. And so we didn't really do this. I scratched it, we touched upon it, but we didn't really work with problems like this, like how logs work, the rules of logarithms. We call it the law of logarithms on page 538. So take a look at 61. Basically, when you have the log of A times B, we can split that up as the log of A plus the log of B. So in log land, multiply means add, as long as it's got the same base. And these are base 10, so it is the same base. All right? Why would we do that? Well, think. Remember, logs are just a fancy way of writing exponents. So when we have like x squared times x to the 5th, when we had like bases, we added those exponents, x to the 7th, 2 plus 5. So we're basically just doing the same thing. You're multiplying, you add up the exponents. This is a fancy way of writing exponents. So when you have the log of something times something else, you can think of it as the log of A plus the log of B. It's using this kind of rule that you're used to doing. All right, you're probably not used to working and manipulating logs. So for part A of 61, they have, what if we have the log of 5t? Well, you could write that as log base 10 of 5 plus log base 10 of t. So you can split that up, okay? What if we have log of pq? You could have log base 10 of p plus log base 10 of q. All right? So get 62. What about divide? Well, think about that. When I had x to the 10th over x to the 7th, you took 10 minus 7, right? And got x to the 3rd. Okay? So if I have a log that is being divided, I can split that up into log A minus log B for that same kind of reason. All right, so that's the rule. And so then let's apply that rule on number 62. We got the log of 7 over y. That is the log of 7 minus the log of y. Those are both the same base, base 10. Log d divided by t, we'd have log base 10 of d minus log base 10 of t. All right? And there's one other rule that I'd like to look at, which is the power rule. And with the power, if there's a power on this, you can pull it down front. So let's look at 63. And then we'll apply these rules. So if you have log base 10 of b raised to the a power, what you can do, a little Price is Right, come on down. You pull that down in front, and you got a log b, all right? And that's like when you have an exponent raised to an exponent, you multiply. So we're pulling it down and multiplying, all right? So let's look at 63 examples. So if I have log of 25 to the 1.2 power, well, that could be written 1.2 times the log of 25. All right? And if I have log base 10 of v to the 5th, well, I could write that 5 log base 10 of v. You just come on down. You pull that exponent down in front. All right? So now let's put these, let's do all of them in one shot here. They're trying to trick us. So let's look at a tricky one, 67. They've got, all right, log of m over t. So if I have that, we can take log of m minus log of t. Now, this one and this one are tricky. R minus s and log of v plus t. Not possible. You can't change that. It's just going to be log of r minus s. It's in log land, divide means subtract, and multiply means add. But if it's already being subtracted or added inside the parentheses, you can't do anything with it. So they're trying to trick us there. Do not be tricked. Why? So multiply means add in log land. Alrighty dighty. Let's do one more in this section. We'll press on to the next one. So we've got number 71. It is log of 1.2r to the 1.5 power. Okay. Interesting. Using as many laws as possible. Write each of these equivalent form. Okay. B. We've got the log of 357 over 298 times, or rather raised to the 1.67 power. And C, we've got the log of 20, 1 plus I, 15. Okay. Interesting. Okay. So we can split these up. So this one is a tricky one because it's not 1.5 raised to the whole power. So let's split it first. Log of 1.2 plus log of r to the 1.5. So we split it first. Now we can do the come on down. And so log 1.2 plus 1.5 log r. And that's the answer. Okay? So that was a tricky one because the 1.5 has no effect on this 1.2. This is a different story. We can pull this down in front, 1.67 times the log of 357 divided by 298. And now we can write this as two different logs. So 1.67 times quantity log 357 minus log 298. Okay. If you wanted to, you could do the distributive property and write 1.67 log 357 minus 1.67 log 298. But you don't really have to. But you could. All right, same thing. This one's really the same as that one. It's just the log of 20 plus the log of 1 plus I raised to the 15th power. So that 15th power has nothing to do with the 20. It's only on that 1 plus I. So we bring that down front, and our final answer is log 20 plus 15 log 1 plus I. All right. Lovely, lovely. Let's do 12.8. Using the laws to rearrange log formulas. Okay. So take a look at 74. We have m, 2.5 log I sub 1 over I. Solve for I sub 1. Okay. No, solve for log I sub 1. Oh, you got to read these very carefully. I'm going to write it down. Log of I sub 1. That's a different story, because then we would first divide by 2.5 regardless. When we do that regardless, let's see. Yeah. That is the correct first move. So we have m over 2.5 equals log of I sub 1 minus log of I. Now they want me to solve for this. So I don't have to divide, you can't really divide out the log. You'd have to rewrite it as a base 10 in order to get I sub 1 completely isolated, but they don't want you to do that. They want it solved for log of I sub 1. So we add the log of I to both sides, and we're done. Plus log of I is equal to log of I sub 1. Done. Okay. So that is a little bit tricky. Let's do one more tricky one, number 80. Okay. So solve, write the formula in simpler form. Oh. Okay, well that's not that tough. They just want V, so they wanted V, but instead of taking these, dividing it and squaring it, we could pull that down in front and just make it 20 log of r sub 2 over r sub 1. I thought they were going to have us like solve for r sub 2 or something, or log of r sub 2. But they just wanted to simplify it a little, so that's all they wanted for that one. All right, let's take a look at 12.9. We're going to look at 83. So they want me to solve this. And so I will show you a couple of ways we can solve this. On 12.9, all right, so we got number 83. It is 456 is equal to 559 raised to the t power. And they want me to solve for t and round to thousandths. So how do we do that? Well, there's two ways to do that. One way is, and this is how most students like to do it, you kind of take the log of both sides. Now, how do I know to do that? Well, anytime that you have a variable trapped up as an exponent, this is likely the route you're going to take, because what can we do? We can say, calm down. And now we divide by log 559 and divide by log 559. And now, there is a huge mistake that happens a lot of the times when people do this. So be careful not to do this. When you are keying this in, you hit the log button, it throws up a parenthesis, you hit 556, end that parenthesis, end parenthesis, end parenthesis, end parenthesis, divided by the log of 559. This one doesn't really matter if you throw that on there, but this one is very important. Otherwise, you get the wrong answer. So log of 456 end parenthesis divided by log 559, enter. So we're looking at 0.96787. What do they want? Thousandths? Thousandths. 9.68. All right. Now, if you just tried to do that on your calculator, but you forgot that parenthesis, this is the wrong answer. Your calculator would have told you. It would have told you 2.22. If you got 2.220, you forgot this parenthesis. And what it did was it took 456 divided by the log of 559 and then took the log of that. And that's not what we want. We want the log of 456 end parenthesis divided by the log of 559 in parentheses. All right? So don't forget that parenthesis on that one right there. That's a very, 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 very common mistake. All right? And then, another way to do this is if you wanted to write it like it was in log land, and most people don't do this, but just in case if you had an algebra teacher that showed you this at some point. Remember, 10 squared equals 100 can be written as log base 10 of 100 is equal to 2. So we could do this. We could say, log base 559 of 456 is equal to t. Except, depending on how fancy your calculator is, if you bought like an upgraded TI-84, it might let you put in whatever base you want, like a different log base and a number, and you could just type it in and hit enter. And then this might be the easier way to do it. But in general, I think this is the easier way to do it. Take the log of both sides, pull it down, divide. If not, if you can still do this with different bases, you just do the log base 10 of 456 divided by the log base 10 of 559. That's called the change of base formula. And if you look at that, that's exactly what we did here anyway. So most students don't do this. Most students do it this way, where you take the log of both sides. Let's take a look at number 86. That's a different type of problem with exponents. So we can take number 87. We've got 9 is equal to, or 86 rather, I'm sorry, 86. I don't want to do 87. I want to do 86, I was looking at the wrong one. 60.7 is equal to t to the 2.6 power. And so you think, okay, well, how am I going to do this? And it's actually just, you just do this, keying it into your calculator. So let's go back and think of an easier problem. When I had like t squared was equal to 25, I said, oh, I'm going to take the square root of both sides, right? Plus or minus the square root. And then t was equal to plus or minus 5. And usually we're only worried about the positive. Think about what the square root is. The square root is to the 1/2 power. So I could have thought of it like this. I could have said t squared equals 25. Take this to the 1/2 power and take this to the 1/2 power. 1/2 times 2 is 1, so you have t to the first, and 25 to the 1/2 power is 5. So following that logic, that's what we want to do here. So let's take each to the 1 over 2.6 power. 1 over 2.6. So basically you take it to the reciprocal power. And now that times that, you get 2.6 over 2.6, which is 1. And 60.7 to the parentheses 1 divided by 2.6 power. Let's see what that is. 60.7 raised to the power of parenthesis 1 divided by 26. And, oh, wait. 2.6 end parenthesis is 4.851117616. And so they don't want that many places. They only want hundredths. So 4.85. I think that's the easiest way to do it. You could take the log of both sides, pull that 2.6 down, but then you have to rewrite it. This is definitely the easiest way to do it. This is, I'm not even going to demonstrate the other way. That's the way to do it. Just do 1 over whatever power that they have, like the reciprocal. All right. Let's jump to 12-10. And then we got to still look at semi-log and multi-log. All right. So evaluating exponential formulas. So 12-10, number 96. So we're number 96, all the way on page 549. They have TV to the 0.4 power is equal to B. And they want me to find T when V is 200 and B is 2750. And so you don't really need this section to do it, right? You could take 200 to the 0.4 power. We've worked exponents already. It's just the ugly number, that's all. That's 8.325532074. T is equal to 2750. And so divide the 8.3 blah, blah, blah. Divide 8.3 blah, blah, blah. And so 2750 divided by second, and then the negative button is answer, so I don't have to type in 8.3 blah, blah, blah. That is 330.3092193. And that they want me to round to the whole number, so 330. So we didn't really need logs or exponents. This was something that we could have did in the first chapter. That's just a little trip down memory lane. Let's look at 1211. So these do get a little strange, especially when you're looking at the graph. So 12.11. Looks like this. Let's go 110, that's on page 555. So what's point B, what's point C? I'm gonna have to do this graph. There's not really a good way to explain this. So it goes 1, 2, 4, 6, 8, 10. So these are all spread out by 2's. But then it asks, hey, what's this one? A. And then they got a hack mark, and then B. And then they've got a hack mark, and then 100. And then a hack mark, and then C. And then a hack mark, and another hack mark, and then D. And then 10,000. So they changed the whole everything here, you guys. You gotta look at this, and girls. Let's take a look. Point B is what? Point C is what? Point D is what? So what they did was they changed they don't have even hack marks. They change it. It's going by 2's, 2, 4, 6, 8, 10, obviously. But then if you look from this, 10 to 100, these are changed. So if it's 10 to 100, but then we have 1, 2, 3, 4 hack marks to get from 10 to 100, then what are we going by? 20, 40, 60, 80, 100, right? So 20, 40, 60, 80, 100. So they went from going by 2's to going by 20's. So B is 60. Then we got 100, and then we got 1, 2, 3, 4 hack marks, and then 10,000. So what are they going by? 200, 400, 600, 800. Nope, that would be just 1,000. So that's, oh wait, it is only 1,000. Okay, good. Phew. I thought it was 10,000. It's 1,000. I wrote that wrong. I was like, ooh, that's going to be a little tougher. This isn't that bad. So now they changed it again. From 100 to 1,000, we have to go by 200s, right? So 200, 400, 600, 800, and then 1,000. So each hack mark is the same amount from this one to this one, even though they're kind of spread really weird. But you have to kind of change the scale each time. Each time there's a scale change. And so that would be, what do they want? C is actually at 400 and D is actually at 800. All right. So that's kind of weird. So be ready for that. On a 3-cycle scale below, even numbers from 1 to 10 are calibrated. So they're calibrating it. Point A is 20. So they did tell us 20. What are the numbers for the other ones? But we had to figure out C and D on our own. All right. So let's look at this. Is really weird with 116. Take a look at 116. And you know I'm deficient at drawing things. So I'll do my best. It's, again, different scales, so you're not an even scale, so you have to really pay attention to what the scale says, okay? And so we've got one scale that's going up by 100, but then it changes to going up to 1,000, and then it changes again going up to 10,000. All right, and then the scale going across the bottom doesn't change. That's just 1, 2, 3, 4, 5, and 6. So when you look at this, it starts down here and goes like that. All right, so A is 1 click below 100. And so that's going to be, is it 1 click or 2? Oh no, it's 2 clicks below, sorry. So that's A. So there's actually 2 little hack marks. You gotta really look, man, that's really hard to see, but there are 2 little hack marks, 2 lines before we get to A. So if it's 100, then that would be at 80. So 1, 80 is point A. Point B, that's off of 1,000. So we're in a different scale, a different Y scale anyway. So B is, looks like it's hitting at 2.5. Oh, it's not even an even number on that. So 2.5, and then you follow it up to B, and now we have to look at, count it, how many lines, either from the bottom or the top, it doesn't matter, but it's going from 100 to 1,000. So those are going by hundreds. So 200, 300, 400, 500, right? 2, 3, 4, 5, 500. So that's 5 lines above this. And so 500. And then C, that's in a different scale again. From it's going from 1,000 to 10,000. And C is up there at 5.5. So we look at where does 5.5 hit, and that's 1 line above 1,000, 2, 3. So that's 1,000, 2,000, 3,000, 4,000. That's going to be 4,000, and at 5.5. So it's weird because you have like 3 different scales to work off of. You just count from the bottom, but you have to change the scale. So that's a little, that's called a semi-log graph, and that's a little confusing. And so it's different than how we've seen it. So when you get to that on the review and the test, my suggestion is that you take your pencil or a pen or whatever and actually section it off so that you give yourself a reminder that each one of these is different. It's scaled differently. So this is just going by tens, this is going by hundreds, and that one's going by thousands. And so those different scales are going to end up with vastly different Y values, even though the distance looks about the same. All right. Okay. That is chapter 12.